Limits have been our initial topic this semester. They're the starting point for our discussion about calculus. Now we want to transition into talking about the derivative, starting with some foundational concepts that we've seen in previous courses. We're going to build up through some ideas and see how we use limits and those rules and properties we've already established to construct this concept of the derivative, which will be our focus for most of this semester. We want to start off by looking at average rate of change and the secant line. In example 1, we're given a solid curve in blue, which is the graph of a function f, and then the dashed red line is what we refer to as the secant line, passing through 0, f of 0, and -2, f of -2. So the secant line is constructed by choosing any 2 points along the curve and connecting those with a straight line. We can find the equation for that line, we can find the slope of that line, and the slope of that line gives us the average rate of change of our function over that range of x values. In part A, that's what we're asked to do. We want to find the average rate of change for this function f, meaning we want to find the slope, m, of this line that we have. To do that, we'll take the difference of our y values minus the difference of our x values, which we pull from those 2 points that are intersecting with our curve. We can see that those points are -2, -1, and 0, 3. It doesn't matter which points we refer to as y2 and y1 or x2 and y1 or which values, as long as we're consistent. So in the numerator, if we use 0, 3 as x2 and y2, we would start off with 3 minus our other y value, which would be -2. Since we started off with 3 in the numerator, we have to start off in the denominator with its corresponding x value. So the denominator will be 0 minus, let me go back, I made a mistake there. That should be 3 minus -1. And then in the denominator, we'll take the difference of the x values, so 0 minus -2. Notice that we have some double negatives that will cancel out here, leaving us with 4 over 2, or a slope of m equals 2. So finding the slope of that secant line that passes through these 2 particular points gives us the average rate of change for that function between those 2 points. Then we can go ahead and find the equation for the secant line itself. Since we know that this is a line, we're going to be constructing an equation of the form y equals mx plus b. We already know our value for m, which is 2. So to find that y-intercept, that value b, we need to plug in a value for x and y. We can choose any point that our line passes through. It's convenient to choose one of the 2 points that we have indicated here, but any point along the line will work. That means we can substitute in 3 for y is equal to 2 times 0 plus this unknown value for the y-intercept of b. 2 times 0 will just be 0, so we'll end up with 3 is equal to b, meaning our linear equation in slope-intercept form will be y equals 2x plus 3. We can repeat that with another example. Again, in part A, we have a new function, a new secant line, which is just constructed by selecting 2 points and drawing the line that passes between those. To find our slope, we'll take the difference of the y values divided by the difference of the x values, and we can see that our curve is passing through -3, 2, and 3, -4. If we take the difference of the y values as -4 minus 2, then we need to make sure we stick with that same order, use the corresponding x values. So our denominator will be 3 minus negative 3. We have a double negative in the denominator that will cancel out, leaving us with negative 6 over 6, or negative 1 as our slope. Again, the slope being that average rate of change. And now to find the equation for the secant line, we can plug in that slope that we know, m is negative 1, and we can choose either coordinate pair. I'll go with 3 comma negative 4, meaning we'll substitute in negative 4 for y, and plug in 3 for x, to then solve for that value b. We have one step that we need to take here, one algebra step, where we'll add 3 to both sides to isolate b by itself, to get negative 1 is equal to b, meaning that the equation for the secant line in this case is y equals negative x minus 1.